Vision can see how eagerly the fish are eating. Sonar can track their movement in 3D, maybe gauge if they're getting full. And algorithms have gotten really good, like over 92% accuracy at spotting uneaten feed pellets sinking down.
Over 92%. So you can adjust the feeding almost immediately if you see waste.
Right away. Cut waste, improve that feed conversion ratio, huge impact on the bottom line.
A whole new era of communication in the global aquaculture industry is coming. Now you have the brightest minds in aquaculture right in your pocket. And what's best? You can listen to all of them while driving to a farm, traveling, or running errands. It's never been this good, and it's never been this simple. Welcome to the Aquaculture Podcast Show, the first AI-based podcast in aquaculture, where you'll find cutting-edge insights in everything that's working in aquaculture, nutrition, health, and production.
Welcome to the Deep Dive. Today we're digging into the future of U.S. aquaculture. We're talking intelligent fish farms and the tech that makes them tick.
That's right.
We've got some solid research here, and our goal is really to pull out the key technical details for you.
Yeah, it's important because, well, traditional fish farming has its share of challenges. Water quality going downhill, diseases popping up, finding enough labor, plus all the environmental pressures.
Right. So this shift towards intelligent farms powered by tech and AI, it's a response to that.
Exactly. It's about using sophisticated systems, AI-driven decisions to tackle these issues right here in the U.S.
Okay, let's break down the tech. When we say intelligent fish farms, what are we actually talking about infrastructure-wise? What's the backbone?
Well, fundamentally, it's built on the Internet of Things. Think loads of sensors everywhere, constantly gathering data.
Okay, sensors everywhere.
Yeah, and to handle all that data quickly, you often see edge computing being used for initial processing right there on site.
Makes sense. Less lag.
Precisely. And then, especially for bigger or more remote farms, you need solid connectivity. Things like 5G are becoming crucial to link everything up reliably.
So beyond just fixed sensors, what about things that move? What mobile tech are we seeing?
Oh, unmanned systems are huge. We're talking UAVs, drones for like an eye in the sky over ponds.
Right.
Then USVs, unmanned surface vehicles doing various jobs on the water, ROVs, underwater vehicles for the really critical stuff, like checking cages and equipment below the surface.
And these aren't just empty vehicles, presumably?
No. They're packed with sensors, cameras, special tools, all geared towards monitoring the environment, checking fish health, estimating how many fish you've got, that kind of thing.
This feels like a pretty big leap from, the old ways. How does this actually look in different farming setups here in the States?
We can sort of group them into four main types, these smart production modules. First up, you've got your pond systems.
Okay.
Here you might see those UAVs for wide area monitoring, but also these bio-inspired robotic fish swimming around underwater.
Robotic fish. Seriously. That's interesting. How do they work compared to just sticking a camera down there?
Well, the idea is they're less intrusive. They can mingle a bit more naturally, observe behavior over longer periods without spooking the actual fish as much. You get different data that way.
Oh.
And the AI takes data from the drones, the robofish, other sensors, and uses it to automate things like keeping oxygen levels right or making sure feed goes where it's needed.
Got it. What's the second type?
Then you have the land-based recirculating aquaculture systems, RAS. These are already pretty controlled, closed-loop setups.
Right, the tanks.
Exactly. Here, intelligence is really driven by crunching huge amounts of data, big data analytics to fine-tune everything. Stocking densities, water parameters, biosecurity protocols. It's all about optimization.
And for farms out in, say, lakes or the ocean.
Right. So for cage-type systems, whether they're fixed or floating, technology like sonar and advanced machine vision is getting integrated more and more.
What do they use sonar and vision for?
Primarily for tracking fish movement, getting accurate biomass estimates how much fish you actually have in the cage, and automating tasks.
Like feeding?
Like feeding, definitely. But also cleaning the nets and even helping with harvesting, like using automated systems to lift nets or transfer fish.
Okay, that covers cages. What's the last archetype?
The fourth is what we might call intelligent marine ranches. These are usually bigger operations, often further offshore.
So larger scale challenges.
Yeah, and they often use a layered approach, maybe satellite remote sensing for the big picture overview, combined with high-res data from underwater robots and networks of acoustic sensors on the seabed or in the water column.
It sounds like AI is really the brain behind all of this, tying it together.
Absolutely, it's central.
Let's dive into some specific AI applications then. Water quality is always a big one in aquaculture, right?
Always. And one of the really neat things happening is what's called soft measurement.
Soft measurements?
Yeah. Instead of needing dedicated sensors for every single parameter all the time, which gets expensive and complicated fast, you train AI models on the easier to get data. Things like temperature, dissolved oxygen, pH.
Okay.
And using clever machine learning techniques, things like LSTM, SEM models the AI, learns the relationships, and can predict the harder to measure but critical stuff, like ammonia, nitrogen, or chlorophyll levels.
And how well does that prediction work?
Really well, actually. The research shows prediction accuracy often hitting over 95%. That gives farmers a heads up, maybe hours or days, to fix a potential problem before it becomes critical.
Wow, 95% plus. That's powerful. You can prevent die-offs, reduce emergency treatments.
Exactly. It's proactive management based on inferred data.
So the AI basically figures out water quality from related clues.
You got it. And that ability ties directly into another huge area.
Okay.
Optimizing feeding. Feed's a massive operating cost, right?
The biggest, usually.
So even small improvements in how efficiently you use feed make a big difference economically. AI algorithms pull in that water quality data, the estimated biomass, and even observations of fish feeding behavior. Through cameras, mostly. The AI calculates super precise feeding schedules and amounts. Some systems even use sensors and remote controls, maybe manipulate lighting to get the feed dispersed just right.
It's not just about how much feed, though. It's making sure they actually eat it, minimizing waste.
Exactly. That's key. So you have machine vision systems, maybe sonar too, watching the feeding happen in real time.
What are they looking for?
Vision can see how eagerly the fish are eating. Sonar can track their movement in 3D, maybe gauge if they're getting full. And algorithms have gotten really good, like over 92% accuracy at spotting uneaten feed pellets sinking down.
Over 92%. So you can adjust the feeding almost immediately if you see waste.
Right away. Cut waste, improve that feed conversion ratio, huge impact on the bottom line, like you said.
Okay, so we've covered the environment and the feed. What about understanding the fish themselves better, using AI? Health and welfare.
Yeah, that's a critical piece. Fish behavior changes subtly when something's wrong: stress, the start of a disease, bad water conditions they don't like.
Things a person might miss just watching occasionally.
Definitely. So AI models analyze movement patterns picked up by underwater cameras or sensors. They look for anomalies, deviations from normal behavior that could signal a problem brewing.
So it's like automated vigilance.
Pretty much. And there's also passive acoustic monitoring, basically listening underwater.
Listening for what?
Sounds linked to specific behaviors, like spawning activity, or even sounds associated with aggression or stress. It gives you another layer of insight into the stock's well-being and social dynamics.
So AI provides this continuous behavioral baseline check that's just not feasible manually.
Not at scale, no. Okay, now think about just running the farm day to day. Routine stuff like checking equipment, knowing how many fish you have. How does intelligence help there?
Good question. Inspection and counting.
Right. Autonomous inspection and biomass assessment are major wins. You use those drones and ROVs we mentioned earlier to do routine visual checks. Look for damage to nets or pipes, see if equipment needs maintenance, check cage integrity.
Saves a lot of dive time, I bet.
Absolutely. And for figuring out how many fish and how big they are, biomass estimation, computer vision is making huge strides.
How does that work? Pointing cameras at fish.
Essentially, yeah. You've got 2D systems, but also more complex 3D setups, like stereo vision, that can measure length and width pretty accurately underwater. Then sophisticated object detection algorithms, enhanced versions can count and size fish very quickly, with reported accuracy up around 91.3%.
91.3% accuracy on counting and sizing. That's solid.
It is, and there are other tools too. Laser scanning works well for stuff on the bottom, like shellfish. Echo sounders and dual-frequency sonar are reliable for biomass estimates even when the water's murky.
What about those really big marine ranches?
For those huge areas, you even see satellite remote sensing being used, trying to infer large-scale biomass trends by analyzing ocean data temperature, chlorophyll patterns, things like that.
This move to automated checks and counts must be way more efficient and probably more accurate than just netting a few samples.
Oh, for sure. Big improvements.
Yeah.
And that carries through right to the end. Harvesting.
How is harvesting getting smarter?
Well, you're seeing things like sonar-guided trawls that are more precise, fish suction pumps designed to be really gentle, minimizing stress and damage.
Suction pumps.
Yeah, gentler than netting sometimes. And even robotics coming in for specific tasks, like harvesting sea cucumbers precisely off the seabed using robotic arms, maybe guided by cameras.
Precision seems key.
It is. Using GPS, computer vision guidance, it allows for more selective harvesting. You take the fish you want, disturb the others less, and maintain the quality of the product.
Okay, so just to try and wrap this all together, the intelligent fish farm really hangs on this combination of IoT for getting the data,
Right, the sensors.
AI for making sense of it, driving decisions,
Your brain.
good connectivity like 5G to tie it all together,
Yeah.
edge computing for quick local responses,
Yep.
those unmanned robots, air, surface, underwater for doing the physical tasks, and underlying it all, big data analytics to keep optimizing everything.
That's a great summary. And we saw how these pieces come together in different ways, right? From the ponds with UAVs and maybe robofish to the highly controlled land-based RES systems optimizing their loops, the cage farms using sonar and vision, and those big marine ranches using satellites and underwater bots.
And we talked about the specific AI wins, that soft measurement for water quality prediction being incredibly accurate.
Over 95%, yeah.
Crucial. The AI-driven feeding that cuts waste using vision and sonar.
Hitting over 92% on uneaten pellet detection.
And getting those deeper insights into fish behavior for health and welfare.
Exactly. Don't forget the acoustic monitoring, too.
Right. Listening in. And finally, those big steps in automated inspection and really accurate biomass counting with vision, sonar, lasers, leading to smarter, quality-focused harvesting.
Couldn't have put it better. It really represents, I think, a fundamental shift for U.S. aquaculture. It's moving towards being much more efficient, much more secure from a biosecurity standpoint, better environmental control, and ultimately, a more sustainable industry driven by data and automation.
It's a fascinating picture of where the technology is heading. Thanks so much for breaking that down for us.
My pleasure. It's an exciting field.
If you enjoyed this episode, make sure to follow the Aquaculture Podcast Show on your favorite platform. And don't forget to follow us on LinkedIn, Instagram, and Facebook to stay updated on the latest episodes and industry insights. Thanks for tuning in, and we'll catch you next time.